In our last video, we looked at finding the probability that Albert Pujols gets exactly 2 hits in his next 3 at-bats. In this video, we're going to look at the question, what is the probability that he gets at least 2 hits in his next 6 at-bats? So what makes this question different is the at least part. When we say at least 2 hits, we don't mean exactly 2 hits, we mean at least 2, which would mean that he could either get 2 hits, or 3 hits, or 4 hits, or 5 hits, or 6 hits. And all of those satisfy at least 2 hits. Now there's a couple different ways in which we can solve this. We could use the same method we did in the last video, find the probability that he gets exactly 2 hits out of 6, and then the probability that he gets exactly 3 hits out of 6, and exactly 4, and exactly 5, and exactly 6, and add all of those 5 numbers together. And that would give us the right answer. Though it would take a little bit longer, and we actually have a shorter way of doing it. So first what we're going to do is actually answer a similar but different question. And that question is, what is the probability that he gets less than 2 hits in his next 6 at-bats? Which is the exact opposite of the question that we were originally asked, the probability that he gets 2 or more hits, or at least 2 hits. So the probability that he gets less than 2 hits would be the probability that he gets either 0 hits or just 1 hit. And the reason we want to answer this question before we answer the other question is because we can answer this question a lot easier, which then enables us to answer the other question in a very easy way as well. So we have another function in the calculator, the Binomial CDF function. It stands for cumulative density function, cumulative meaning add up, where we put numbers in the same way. The first number is n, the number of trials. The second number is p, the probability of success. And the last number is x, the number of successes. But in this case, the Binomial CDF finds the probability of x or less successes. So if we do Binomial CDF, where there are 6 trials, 6 at-bats, probability of success 0.320, Albert Pujols batting average, and 1, what that's going to find is not just the probability that he gets 1 hit, but 1 or less, which would be 0 or 1. So writing Binomial CDF 6.320 and 1 would be the equivalent of doing 2 Binomial PDF functions. 6.320 0 plus Binomial PDF 6.320 and 1. So the Binomial CDF function sums up a couple of them. Anything less than. Now, the less was just chosen by whoever designed the TI-84. There's not really a mathematical reason why it's x or less. They could have just as easily programmed the calculator to do x or more, but they chose less. So we're always going in the less direction. So to find the probability that he gets less than 2 hits in his next 6 at-bats, we'll calculate Binomial CDF 6.3201. And let's see what that is when we go to our calculator. So within the same spot as the Binomial PDF, we go to second and then distributions, and then we'll scroll down. So Binomial CDF is right below Binomial PDF. And so we're going to put in our trials as 6, our probability of 0.320, our x value of 1, and so again that's going to find not the probability that he gets exactly 1 hit, but the probability that he gets 1 or less hits, so 0 or 1. So we'll go down here. Again, some of you may get this menu option that you see here, or some of you may have to type it in this order as we saw in the last video. So again, the first number we type in is n, the number of trials. Second number is p, the probability of success. And the last number is x, the number of successes. And so the Binomial CDF, we get 0.378. And again, I'm going to round that when I write it down on the screen, but you'll want to just keep that number in your calculator. That way you can get an exact answer. All right, so why did we do that? Why did we find the answer to the opposite question that we actually wanted to ask? Well, let's go back to our original question. We wanted to find the probability that he gets at least 2 hits in his next 6 at-bats. Well, one thing we know about probabilities is that they all add up to 1. So one thing we know about this problem is that the probability that he gets 0 hits plus the probability that he gets 1 hit plus the probability of 2 hits plus the probability of 3 hits plus the probability of 4 hits plus the probability of 5 hits plus the probability of 6 hits all has to sum up to 1. So if he's going to go to bat 6 times, he is either going to get 0, 1, 2, 3, 4, 5, or 6 hits. One of those has to happen. So what we did was we very easily found this right here, the probability of 0 or 1. What we were actually asked for was this right here, the probability that he gets 2 or more, or at least 2. Well, what we can do here is some pretty simple algebra, and we can figure out that if we subtract the probability of 0 and the probability of 1 from both sides, what we would get is that the probability of 2 hits plus the probability of 3 hits plus the probability of 4 hits plus the probability of 5 hits plus the probability of 6 hits would be equal to 1 minus the probability of 0 hits plus the probability of 1 hit. Just subtracting this term right here from both sides. So this right here is what we're looking for, and we can find that very easily by just doing 1 minus that number that we just found, the number that's still on our calculator. So we can do that pretty easily. So we'll do 1 minus that answer. And what we get is the probability of that he will get at least 2 hits. It's about 0.622 if we're rounding to 3 decimal places. So the binomial CDF function, again, sums up the probability of getting X or less successes. So in this case, when we did the binomial CDF for 1 success, what we really got there was 0 and 1 successes summed together. We subtracted that from 1 to get the probability of at least 2 hits in the next 6 at